Okay, one by one. So this is the magnetic effect of electric current. Very simple chapter idu. ಏನು confusion ಮಾಡ್ಕೋಬೇಡ್ರಿ. First of all, if there is a conducting wire, if it is a wire, conducting wire, if it is connected to a battery, so what happens around this? There will be magnetic field. ಇದನ್ನೇ ಪ್ರೂವ್ ಮಾಡಕ್ಕೆ ಏನ್ ಮಾಡಿದ್ರು? There was one experiment by the Oersted experiment ಅಲ್ಲಿ they kept the compass here, isn't it? They kept the compass here, and what happened when they switched on the key? So key model. So when they switched on the key, there was current passing through the conductor, and there was deflection. There was deflection. So ಈ ಕಡೆಯಿಂದಾಗ ಒಂದು ಕಡೆ deflection ತೋರಿಸ್ತು. Suppose if the current is flowing through the other end, the current is flowing from this end, no? So it showed the deflection on the other side. By the deflection, they came to the conclusion of this experiment. ಇವೆಲ್ಲ ನೆನಪಿರಬೇಕು ನಿಮಗೆ. You should write the conclusion for every experiment. ಏನದು? Current carrying conductor will have a magnified ಏನದು? Will have a magnetic around it. So current carrying conductor will have a magnetic field around it. This was the conclusion by the Oersted experiment. To understand this, what is magnet and what is magnetic field, we took a bar magnet, north pole, south pole. So with the help of a compass, they drew these lines, which are called as ಏನು ಹೆಸರು ಕೊಟ್ಟಿದ್ದೀವಿ?
Field lines.
Field
lines. And every field line will have its property. What are the property? They start at the north pole and end at the
South pole.
South pole.
Pole and end at the south pole. So these were the properties. So start at one pole, end at another pole. Inside the magnet, it will be from south to north. Inside the magnet, it will be from south to north. All of you should be able to draw this diagram. So wherever the force is present, that is called magnetic field. So ಎರಡಿತ್ತು ಕಾನ್ಸೆಪ್ಟ್. ಒಂದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, ಇನ್ನೊಂದು field lines. What is magnetic field? Wherever we feel the force of the magnet. The force may be two. ಏನೇನು? One may be attraction, second may be repulsion. So north pole, if you bring near to each other, they will not attract, they will repel. That is called repulsion. If north and south are brought near to each other, they will attract. This is called as attraction. So these two are the forces. So near to the magnet, if we feel this force, it is called a magnetic field. And these are the field lines. Field lines are responsible for that force. A force is responsible arrow, this field lines. So the first point is they start at north pole and end at the south pole. Inside the magnet, they start at the south pole and end at the north pole. Next, third property. The intensity of the magnetic field. If the magnetic field, you can see, dur hodange lines doddu akkonta hogutave. The distance between these two will go on increasing. So if they are crowded, means if the lines are crowded, the magnetic field is more. The intensity of magnetic field is more. If they are not crowded, the intensity of the magnetic field is very less. So ಎಲ್ಲಿ ಜಾಸ್ತಿ ಇರ್ತಾವಲ್ಲ, ಇಲ್ಲಿ ನೋಡ್ರಿ, ಇಲ್ಲಿ crowded ಜಾಸ್ತಿ ಐತಿಲ್ಲ, there is more crowd here, so here it will attract more than here. ಇಲ್ಲಿಗಿಂತ ಇಲ್ಲಿ crowd ಇದೆ, so it will attract more. And very important point, no two field lines cross each other. ಒಂದು field line ಇನ್ನೊಂದು field line ಗೆ cross ಆಗಲ್ಲ. If they did, suppose ಇದೊಂದು ಲೈನ್ ಹಿಂಗ ಬಂದಿತ್ತು ಅಂದ್ರೆ 1 2 3, see it is crossing all the field lines. If you keep a compass here, ಇಲ್ಲಿ ಕೆಳಗೆ ಒಂದು compass ಇಟ್ರೆ, the compass has to show north and south both the side, which is impossible. So these 4 or 5 properties of field lines are very important. So you learned about the properties, and even you learned the 5th one it has both magnitude as well as direction. Magnitude andre it has some force. Every magnet will generate a force. Sun magnet idre sun force, dot magnet idre dot force. So that force is magnitude here. So distance magnitude enandre meters baritivilla, that is called magnitude. These have even the direction also. For the direction we had experiment. Innondu experiment ide. What was the experiment? A battery was connected. I hope all of you have drawn this diagram. A compass was kept here. Actually, this is north, south, east, west. All of you know the direction, no? North, south, east, west.
Yes, sir.
Now, when this was the condition, a compass was kept here, which was showing north pole. Nodri, north pole ತೋರಿಸ್ತಾ ಇದೆನೋ, it is showing towards the north. Same method. ಈ key ಹಾಕ್ತೀನಿ. Key ಹಾಕಿದ್ರೆ current starts passing. So when current starts passing, look what happened to the. Is it showing north pole now? It turned towards east side. It turned towards east side. So second, one more diagram you can see. If I take a compass here, it was showing north pole. You know, see, can you see it is showing north pole? Now I put the key.
Yes,
the current is passing from this end in the positive. E positive in the ikkada hodaga, then you can see it turns towards west side. So in the battery hakidre, when the current was flowing, it deflected towards east. Here it deflected towards west. By this we can tell that field lines will have, the magnetic field will have direction also. So these we learned about the field lines. Idru field lines magnetic field ಬಗ್ಗೆ ಕಲ್ತಿ. What did you learn after this? ಏನ್ ಕಲ್ತ್ರಿ ಆಮೇಲೆ? How is the magnetic field in a straight conductor? Correct? Straight conductor.
Yes, sir.
Yes.
So how are the lines in the straight conductor? How are the field lines?
Concentric circles.
Concentric.
They are in the form of concentric circles. So this was with the straight conductor. In a circular loop, illೊಂದು ಕಾರ್ಡ್ಬೋರ್ಡ್ ಹಚ್ಚಿದ್ರೆ so if you connect two ends here, one is connected positive, another is connected negative. Here also we see that they are in the form of concentric circles, but as we move near and near, at the center it forms a straight line.
Straight line.
Correct is the diagram?
Yes,
This
sir.
is for the
Yes.
circular conductor. At the center it appears to be in a straight line. Here also concentric circle, here also concentric circle. I can illu straight then straight iruttale, but when they become bigger and bigger, the distance goes on increasing, and at the center it becomes in the form of a straight line. Next, about the solenoid. If the number of turns increases, the magnetic field also increases. How it increases? So here it is. So when you connect the battery from this end, so you will get the magnetic lines of force. So when you connect, this side becomes north and this side becomes south. So this is called a solenoid. What is solenoid? First tell me what is solenoid?
It is a cylindrical shape.
It is a cylindrical shape. If wire is coiled to the cylindrical shape. Such shape forms the solenoid, and this solenoid is nothing but a bar magnet only. ಇದು bar magnet ಎರಡು same. So it also behaves like a bar magnet. So what happens next? Suppose if we keep a soft metal, ಯಾವುದೋ ಒಂದು ಸಾಫ್ಟ್ ಮೆಟಲ್ ಇದ್ರೊಳಗಿಟ್ರೆ ಒಂದು ಅರ್ಧ ತಾಸು ಒಂದು ತಾಸು ಎರಡು ತಾಸು ಇಟ್ರೆ what happens? This soft metal converts into a magnet. The soft metal ಹೋಗಿ ಏನಾಗುತ್ತೆ magnet ಆಗುತ್ತೆ. So the uses of solenoid are very simple. They are used to make electric valves. They are also used to manufacture artificial magnets. ಅದೇ ಹೇಳಿದಲ್ಲ ಸ್ಪೀಕರ್ ಗೆ ಮ್ಯಾಗ್ನೆಟ್ ಬರುತ್ತೆ. They are manufactured with the help of a solenoid. Have you ever seen ಟೆಸ್ಟ್ ಮಾಡಿರ್ಬೇಕು ನೀವು? If you take a screwdriver ಹಿಡ್ಕೊಂಡು ಎಲ್ಲೋ ಸ್ಕ್ರೂ ಹಾಕ್ತಿರ್ತೀವಿ, ಅದು ಅಂಟ್ಕೊಳ್ಳೋದಿಲ್ಲ. So what you can do, a screwdriver ಒಂದು 5 ನಿಮಿಷ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಅಂಟಿಸಿಟ್ರಿ, ಆಮೇಲೆ ಆಟೋಮೆಟಿಕಲಿ the screw will get attached to that. Then you can screw it. Have you seen this?
Yes, sir.
Yes, sir.
You can also make like that. You can make artificial. ಇನ್ನೊಂದು, ಮನೇಲಿ ಮ್ಯಾಗ್ನೆಟ್ ಇದ್ರೆ you can play with this properly. ಮನೇಲಿ ಪಿನ್ ಇರ್ತಾವಲ್ಲ, ಆ ಪಿನ್ನಿಗೆಲ್ಲ ಅಂಟಿಸಿಡ್ರಿ ಓವರ್ ನೈಟ್, ರಾತ್ರಿ ಎಲ್ಲ ಇಡ್ರಿ. ನೆಕ್ಸ್ಟ್ ಡೇ ಆ ಪಿನ್ ತೆಗೆದು ನೋಡ್ರಿ, ಪಿನ್ ಆಲ್ಸೋ ಗೆಟ್ ಮ್ಯಾಗ್ನೆಟೈಸ್. Pin also becomes magnetic in the next morning. Not more time. On ಸ್ವಲ್ಪ ಹೊತ್ತಾದ್ರೂ it becomes a magnet. So this was the solenoid, which we converted the whole circuit complete ಮಾಡಿ ಒಂದು bar magnet form ಮಾಡಿದ್ವಿ. Even here if you interchange, ಈಗ ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಬಿಟ್ ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಮಾಡಿದ್ರೆ, ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಮಾಡಿದ್ರೆ, so here it was positive, here it is negative. So what happens now? Now it becomes north, it becomes south. The direction changes as you change the direction of electric current. Okay. Next, after solenoid, what you had? Right hand thumb rule. Neen nodidri? Right hand thumb rule. All of you were holding your pen like this.
Yes, sir.
Huh? Your thumb represents the direction of current. Current ee kadinda ee kade hontide. Your fingers will represent the magnetic field around it. Now it is coming towards you. Nim kade barta ide. Look at the fingers. They are clockwise or anti-clockwise?
Anti-clockwise.
Yes.
Huh? So this is anti-clockwise for you and this is clockwise for you. Correct? So if it is coming out of it, ಹೊರಗೆ ಬರ್ತಾ ಇದ್ರೆ, so you can understand it very easily. If it is going inside, how it is, you can identify easily. That is the right hand thumb rule. Next, after this we understood we can create a force. How can we create a force? So they took the horseshoe magnet, one side north, one side south. They took another conductor, ಒಂದು ಸ್ಟ್ಯಾಂಡ್ ಹಾಕಿ ನಿಲ್ಲಿಸಿದ್ರು. So here they connected a battery here. So what happened now, when they have connected battery towards this side, it went to the other side. ಈ ಕಡೆ ಹೋಗಿ north side ಗೆ ಹಿಂಗಿತ್ತಲ್ಲ, it went towards north side. So suddenly what they did, direction change. So when they changed the direction, it came back to south. ಈ ಕಡೆ ಬಂತು. By this we can tell that we can generate a force on this conductor which is kept already in a magnetic field. Force on a conductor in a magnetic field was the concept. So with the help of this, ಯಾವ law ಬಂತು? Fleming's which rule? Left or right? Fleming's left hand rule. Fleming's left hand rule is also called as
Motor rule.
Motor rule.
motor rule. So this is how we convert the force here. The left hand rule says 3 fingers. Which are these 3 fingers? Thumb, index, middle finger.
Index, middle.
Mutually perpendicular to each other. What we do in the motor? Fleming's left hand andre confuse agbeಡ್ರಿ ಇವತ್ತು. Write the names of all the 3 fingers. ಮೂರು ಬರೀರಿ. Thumb, index, middle. thumb, index, middle finger. You write the names. Okay, ಏನಾಗುತ್ತೆ ಮೋಟರ್ ಒಳಗಡೆ ಏನಾಗುತ್ತೆ give current. Okay, ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ we give current. Direction of current. Next, here middle index finger is always
Magnetic field.
magnetic field, and the thumb represents the direction of
Force.
motion.
Motor. Motion.
Direction of motion, or we will generate the force here. With the help of force only we get motion. So the motor starts rotating. How to draw the diagram of DC motor? What is motor? Motor is a device which converts electric energy into
Mechanical energy.
Mechanical energy.
So what happens here? We have two poles of the magnet. One is north, another is south. Already there will be field here. Field is there. This is the two-dimensional diagram I am drawing here. Two-dimensional diagram. In the textbook they have given three-dimensional. You can draw this, no problem. So this is DC. In DC we use split rings. We use split rings. So ring 1, ring 2. Here carbon brushes, brush 1, brush 2. It is taken out and we give electricity. This is the diagram of DC motor. So ಇಲ್ಲಿ ಏನೇನಿದೆ R1, R2, brush B1, B2. And this is called the axle. ಇದಕ್ಕೆ axle ಅಂತೀವಿ. And this whole setup ಏನಿದೆಲ್ಲ, this is called as armature. ನಿನ್ನೆ ಹೇಳಿದ್ದಲ್ಲ ಈ setup ಗೆ armature, axle, ಈ axle rotator. So if you want to understand the motor how it works, you have to use these fingers. Notice in positive direction illide, the current is flowing through this and coming back from this. So ಈಗ current, which finger will show current? Middle finger will show current. So if I hold my middle finger, I am holding. Already you can see, no drink. Current illide. Can you all see? This is current. My middle finger shows
Yes,
current.
yes, sir.
And what about
Yes,
index
sir.
finger? Index finger ಏನಿದು?
Magnetic field.
Magnetic
So
field.
there is magnetic field ಇದೆಲ್ಲ. So this is current.
Yes, sir.
This is magnetic. Force ಎಲ್ಲಿದೆ? Coming out. Force is coming
Yes,
out.
sir.
So what happens? It pushes it up. ಇದನ್ನ ಹಿಂಗಿದ್ದನ್ನ ಮ್ಯಾಲ್ ಮಾಡಿ. So again it changes 90 degree. Then what happens? Again when it comes here, ಇಲ್ಲಿ ಬಂದಾಗ ಹಿಂಗ್ ಹಿಡಿತೀನಿ. I will hold it like this. See, this is the current flowing, and this is the magnetic field. And which side is the force going, inside or outside?
Inside.
Thumb is moving inside. Nodri ಒಳಗೆ ಹೋಗ್ತಾ ಇದೆ. Hence it pushes down. ಇಲ್ಲಿ push up ಆಗ್ತಾ ಇದೆ, ಇಲ್ಲಿ push down ಆಗ್ತಾ ಇದೆ. As a result ಹಿಂಗಿದ್ದಿದ್ದು ಏನಾಗುತ್ತೆ? It starts to rotate. Can you understand? ಇದು push up,
Yes, sir.
ಇದು ಮ್ಯಾಲೆ ಬರಬೇಕು. Push down, ಮತ್ತೆ push up, push down, push up, push down. It starts to rotate. This is how we have converted electric energy into mechanical
energy.
ಅರ್ಥ ಆಯ್ತಲ್ಲ ಇದು? How a
Yes,
motor
sir.
works.
What is the use of split rings, sir?
Yes, sir.
Yes.
What is the use of split rings and carbon brushes?
What? Split rings will not allow the change in direction. Direction change ಆಗಕ್ಕೆ ಬರುವುದಿಲ್ಲ. ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಕರೆಂಟ್ ಇಲ್ಲಿಂದ ಹಿಂಗೆ ಹೋಗಕ್ಕೆ ಹೆಲ್ಪ್ ಮಾಡುತ್ತೆ. ನೀವು ಸ್ಲಿಪ್ ರಿಂಗ್ಸ್ ಯೂಸ್ ಮಾಡಿದ್ರಿ ಅಂತ ತಿಳ್ಕೊಳ್ರಿ, ಹಾಫ್ ಸೈಕಲ್ ಈ ಕಡೆಯಿಂದ ಹೋಗುತ್ತೆ ಕರೆಂಟು, ಹಾಫ್ ಸೈಕಲ್ ಈ ಕಡೆಯಿಂದ ಹೋಗುತ್ತೆ. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ? ಅಗೇನ್ ದೇರ್ ವಿಲ್ ಬಿ, ಇಟ್ ವಿಲ್ ರೊಟೇಟ್ ಆಗುವುದು, ಆದ್ರೆ ದೇರ್ ವಿಲ್ ಬಿ ಡಿಫರೆನ್ಸ್ ಇನ್ ದ ರೊಟೇಷನ್. ಸೊ ವಿ ಯೂಸ್ ದಿಸ್ ಡಿಸಿ ಮೋಟರ್. ತಿಳಿತಲ್ಲ? ಸ್ಪ್ಲಿಟ್ ರಿಂಗ್ಸ್ ಇದ್ರೆ ಡೈರೆಕ್ಷನ್ ಆರ್ ಮೇಂಟೈನ್ಡ್ ಪ್ರಾಪರ್ಲಿ. ಸ್ಪ್ಲಿಟ್ ರಿಂಗ್ಸ್. This is the graph of DC charge. DC ಏನಿರುತ್ತಲ್ಲ, ಅದರ ಗ್ರಾಫ್ ಇದು. ಹಾಫ್ ಸೈಕಲ್, because another cycle is cut into parts. This is the wave of a DC. AC the graph ಹಿಂಗ್ ಬರುತ್ತೆ ನೋಡಿ. This is the graph of AC. ಗೊತ್ತಾಯ್ತಲ್ಲ, ಮ್ಯಾಲೆ ಹೋಗುತ್ತೆ ಕೆಳಗೆ ಹೋಗುತ್ತೆ. This is called vibration. ಮೇಲೆ ಕೆಳಗೆ ಮೇಲೆ ಕೆಳಗೆ ಮೇಲೆ ಕೆಳಗೆ, this is vibration. ಆದ್ರೆ ಇಲ್ಲೇನಿದೆ, direct 1/2 of the wave is cut in the direct current. So direct current cannot travel to long distance. ಭಾಳ ದೂರ ಡಿಸ್ಟೆನ್ಸಿಗೆ ಡೈರೆಕ್ಟ್ ಕರೆಂಟ್ ಯೂಸ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ, ವಿ ಕೆನಾಟ್ ಯೂಸ್. ಬಟ್ AC ಕ್ಯಾನ್ ಬಿ ಸೆಂಟ್. ನೋಡ್ರಿ, ಎಲ್ಲೋ ಕರೆಂಟ್ ಜನರೇಟ್ ಮಾಡತ್ತಾರ, ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ ಬರ್ತಾ ಇದೆ, ವಿ ಆರ್ ರೀಚಿಂಗ್. ಸೊ AC, they have both the waves, it can travel for longer distance in a good conductor, very easy. So that's it. This was for the Fleming's left hand rule. Then comes electromagnetic induction. So electromagnetic induction kaltir new already by the Faraday's experiment. Coils are made in the form of solenoid. So we'll end tone in martivi, we connect a galvanometer. So galvanometer il hakittirtini nodri, this is the galvanometer. Ikkade one direction, ikkade one direction, one side negative irutte, one side positive irutte. So galvanometer is the device which measures electric current, even it measures the direction of electric current. So now what happened, they have brought a bar magnet north and south. Situation 1 or case 1. Case 1, it is kept constant. Eradu constant ittare, it is not moving. Step 2, they will insert it inside. They will put it inside. Yavag olaga haktaralla, the galvanometer shows the reading. Ee kade bantu. So hingididina reading ee kade bantu. And case number 2, when it is put inside. Case number 3, they will keep it inside. Ille olaga ittiradana magnet. What happens? Again there is no change. Again it is constant only. Then case number 4, they removed it out. Mat ಹೊರಗೆ. When they removed it out, look what happened. It deflected on the opposite direction. So ಒಳಗೆ ಹಾಕಿದಾಗ ಈ ಕಡೆ ಬಂದಿತ್ತು, ಹೊರಗೆ ತೆಗೆದಾಗ ಈ ಕಡೆ ಬಂತು. It is showing its direction. So what happens? ಇಲ್ಲಿ field lines ಇರುತ್ತೆ. There will be field lines coming out of north, and there are conductors here. Conductors ಇದ್ರೆ ಏನಾಗುತ್ತೆ, ಅಂಟ್ಕೊಳ್ಳೋಕೆ ಟ್ರೈ ಮಾಡುತ್ತೆ, ಬಟ್ ನಾವು ಅಂಟ್ಕೊಳ್ಳೋಕೆ ಬಿಡಲ್ಲ, because all are insulated. We are just changing, we are putting it in and we are removing out. When we are putting it in, it tries to, in copper wire iruttalla, so when we remove it out, the link between these two changes. ಒಂಥರ ದಾರ ಕಟ್ಟಿದಾಗ ಇಲ್ಲಿ ಒಳಗೆ ಹಾಕಿದಾಗ ಜಗ್ಗದಂಗ ಆಗುತ್ತೆ, ಹೊರಗೆ ತೆಗೆದಾಗೂ ಜಗ್ಗದಂಗ ಆಗುತ್ತೆ. The link changes. When the magnetic link, the link between the conductor and magnet changes, it induces current. In ಬರ್ದಿದ್ರಲ್ಲ, electromagnetic induction means when the link between the magnet and the conductor changes, it induces electric current. This phenomena is called as electromagnetic induction. So we have successfully converted, nodri ulta aithu illi, electric energy to mechanical energy, but we are doing mechanical energy, we are getting electric energy. Is it reverse process? In reverse process aitha illa?
Yes, sir.
Yes, sir.
We have motor means electric energy to mechanical energy. Now mechanical energy to electrical energy means it is a generator, which can be expressed with the help of Fleming's right hand rule, which is also called as generator rule. Again, you hold the 3 fingers only. You hold the 3 fingers, thumb, index, middle finger, mutually perpendicular to each other. All the 3 are perpendicular to each other. With this, we can tell that. So what we are doing? We are giving motion from the thumb. Thumb inda motion ಕೊಡ್ತಾ ಇದೀವಿ. Already there is magnetic field, and here we get electric current. ಆಗಲೇ ಇಲ್ಲಿ ಕರೆಂಟ್ ಕೊಡಾತಿದ್ವಿ, ಫೋರ್ಸ್ ಬರಾತಿತ್ತು. ಈಗ ಫೋರ್ಸ್ ಕೊಡಾತೀವಿ, ಕರೆಂಟ್ ಬರ್ತಾ ಇದೆ. ಡಿಫರೆನ್ಸ್ ಗೊತ್ತಾಯ್ತಲ್ಲ?
Yes, sir.
So here all we have a diagram of generator. Generator same diagram ಬರುತ್ತದು. magnetic field, armature. So we will get two types of rings. Ring 1, it is connected here. Ring 2, it is connected. Brush 1, brush 2. So here we will connect. Em connect madave illi?
Bulb.
Bulb. We are connected a bulb. So what happens here? Cycle nodri hang cycle hoguttille north pole, south pole. So here illond handle kottu ತಿರುಗಿಸ್ತೀವಿ. Yesterday you saw, no, they were rotating it. It will start rotating. So what happens? First step ತೆಕ್ಕೊಳ್ರಿ. When we start rotating, ಈಗ ಇಷ್ಟಿದೆ 90 degree, 180 degree. So 90 degree, 180 degree ಅಂದ್ರೆ, so if I give the names A, B, C, D ಅಂತ ಕೊಡ್ತೀನಿ, the current flows from A to B, C to D and comes out from here till 180 degree. Actually ಹೆಂಗ್ ಬಂತಿದ್ದು 0 degree ಏನೋ ಮೋಷನ್ ಇಲ್ಲ ಹಿಂಗೆ ಇದೆ. Next comes 90 degree. With 90 degree the graph goes up, ಇಲ್ಲಿಗೆ ಹೋಗುತ್ತೆ highest point. ಮತ್ತೆ 90 degree ಆಯ್ತಂದ್ರೆ it comes down. Next 270 degree. 270 degree, now the direction changes. ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಬರ್ತಾ ಇತ್ತು. Now what happens? Now the A is here, B is here. ನೋಡ್ರಿ ಇದಿತ್ತು A, B, C, D. 180 degree ಆಯ್ತಂದ್ರೆ automatically A came here, B, C and D. The current flows from A to B, C to D. It comes out from this direction. So ಅಂದ್ರೆ ಇಲ್ಲಿ ಹೋಯ್ತು. 270 degree ಆದ್ಮೇಲೆ again 360 degree. 360 degree comes back. ಮತ್ತೆ ಇಲ್ಲಿ A ಆಗುತ್ತೆ, ಇದು B ಆಗುತ್ತೆ, ಇದು C, ಇದು D, and it continues. So this is how a slip rings. What type of rings we used here? What type of rings? Two
Slip rings.
slip rings. Slip rings. ಅಲ್ಲಿ split rings. ಒಂದೇ ring ಅನ್ನು ಕಟ್ ಮಾಡಿ ಎರಡು ಪಾರ್ಟ್ ಮಾಡಿದ್ರೆ ಹೆಂಗಾಗ್ತದೆ? That is called split rings. Here we used two rings which we call as slip rings.
Slip rings.
So brush 1, brush 2, carbon brushes. Carbon brush ಯಾಕಂದ್ರೆ it will be continuously rotating. ಆ brush connect ಇರುತ್ತೆ. ಹಿಂಗೆ brush ಮಾಡ್ಕೊಂತ ಹೋಗ್ತಾ ಇರುತ್ತೆ. It will receive the current and send outside. So carbon brushes are used. Friction ಕಡಿಮೆ ಆಗಲಿ, spark ಕಡಿಮೆ ಆಗಲಿ ಅಂತ ಹೇಳಿ ಅದನ್ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಬೇರೆ ಏನಾದರೂ ಮೆಟಲ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ spark ಬರಕ್ಕೆ ಸ್ಟಾರ್ಟ್. So they use carbon brushes. I hope the generator diagram is easy. You understood the working of it. Fleming's left hand rule, right hand rule also. Next ಮತ್ತೆ ನೋಡಿತು. ಏನು ನೋಡಿತು?
Domestic electric current.
Domestic circuits. How do we connect the domestic circuits? Adantu easy ಇದೆ ನಿಮಗೆ. So 3 holes. One is live, neutral and earth connection. How they are connected? Everything is connected in parallel or series?
Parallel.
ಇಲ್ಲಿ ಒಂದು ಸ್ವಿಚ್ ಇದೆ, ಇಲ್ಲಿ ಒಂದು ಸ್ವಿಚ್ ಇದೆ, ಇಲ್ಲಿ ಒಂದು ಸ್ವಿಚ್ ಇದೆ ಅಂದ್ರೆ so these are connected live, neutral, earth. This is the parallel connection. Series ಆಗಿದ್ರೆ ಏನಾಗುತ್ತೆ ನೋಡ್ರಿ, series ಆಯ್ತು ಅಂತ ಕೊಡ್ರಿ. Suppose I connected it in series. So live wire ಬಂದು ಇಲ್ಲಿ ಕನೆಕ್ಷನ್ ಕೊಡೋದು, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಬರುತ್ತೆ. ನ್ಯೂಟ್ರಲ್ ಬಂದು ಇಲ್ಲಿಗೆ ಬರೋದು, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಬರುತ್ತೆ. ಆದ್ರೆ ಇಲ್ಲಿ ಹಂಗಾಗಲ್ಲ. ಹೊರಗಡೆಯಿಂದ ಏನ್ ಬರ್ತಾ ಇರುತ್ತಲ್ಲ, ಇಲ್ಲಿ ಹೋಗುದು, ಇಲ್ಲಿ ಹೋಗುದು, ಇಲ್ಲಿ ಹೋಗುದು. ಆದ್ರೆ ಇಲ್ಲಿ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಅಷ್ಟೇ, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ. ಸಪೋಸ್ ಈ ಸ್ವಿಚ್ ಆಫ್ ಮಾಡಿದೆ, ಇಲ್ಲ ಇದು ಏನೋ ಆಗಿ ಕೆಟ್ಟಿತ್ತು, ಸುಡಿತು ಅಂತ ತಿಳ್ಕೊಳ್ರಿ. ದೇರ್ ವಿಲ್ ಬಿ ನೋ ಕರೆಂಟ್ ಫಾರ್ ದಿಸ್ ಆಲ್ಸೋ. ಸೊ ಸೀರೀಸ್ ಕನೆಕ್ಷನ್ ಆರ್ ನಾಟ್ ಪ್ರಿಫರ್ಡ್. Understood? So we
Yes,
connect
sir.
Yes, sir.
parallelly and we use fuse for the safety. Fuse use ಮಾಡ್ತೀವಿ, MCB use ಮಾಡ್ತೀವಿ for the safeness. Fuse also you should choose lightning ಇದ್ರೆ 5 ampere. If you are using mixer grinder, geyser ಅದೆಲ್ಲ ಇದ್ರೆ you have to use 15 ampere. ಇದ್ರೊಳಗಡೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬರ್ಬೋದು. They may give the problems. What kind of problems? In a house, we are having 220 volts of potential difference. 220 of potential difference. If my instrument, if the instrument, the geyser I am receiving, yes, so it is of nearly 1 kilowatt. 1 kilowatt ಇದೆ. What ampere of fuse we will suggest ಅಂತ ಹೇಳ್ತಾರೆ. ಮನೆಗೆ ಬರ್ತಾ ಇರೋ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಎಷ್ಟು? 220 volts. ನಮ್ಮ ಗೀಸರ್ ಕೆಪಾಸಿಟಿ ಎಷ್ಟಿದೆ ಅಂದ್ರೆ ಅದು ವಾಟ್ ಯು ಕಾಲ್ ವರ್ಕ್ how much?
1 kilowatt.
Wattage.
1 kilowatt.
1 kilowatt. It requires lot of current. So ಎಷ್ಟು ಆಂಪಿಯರ್ ಫ್ಯೂಸ್ ಹಾಕಬೇಕು ಅಂತ ಕೇಳ್ತಾರೆ. It is an applied question. It was asked many times. So the formula of power is, ಏನೋ ಇತ್ತಲ್ಲ ಫಾರ್ಮುಲಾ ಪವರ್ P is equal to
V into I.
V into I. So this is given V equal to, this is given power P is equal to. Substitute madri 1000 watts is equal to 220 into I. Divide madri 1000 watt divided by 220 is equal to I. 0 0 2 11s are 250s are 11 1s are 11 4s are 44 6 ಉಳಿತು 0.0. So approximately 4.5 ampere current ತಗೊಳ್ಳುತ್ತದೆ. It will take nearly 4.5 ampere. So what fuse you will suggest? Correct 5 ampere ದ ಹೇಳ್ತೀರೋ ಇದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಹೇಳ್ತೀರೋ?
5 ampere.
Yes. 5 ampere ತಗೊಂಡ್ರೆ 4.5 ಇದೆ. Sometimes 230 ಬಂತ ತಿಳ್ಕೊರಿ. If you get 230 there, current ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಹಾರೋಗ್ಬಿಡುತ್ತೆ fuse. So minimum at least 10 ampere of fuse you have to suggest. This is minimum 5 ampere ಹಾಕಬಹುದು, but it will be risky. So exam ನಲ್ಲಿ ನಿಮಗೆ MCQ ಕೇಳಿದ್ರೆ ಯಾವ್ದು ಸೆಲೆಕ್ಟ್ ಮಾಡ್ತೀರಿ?
10 ampere.
10 ampere. 10 ampere.
You have to select 5 ampere only if the voltage is constant. ಅದನ್ನು ಕೊಡ್ತಾರ ಅವ್ರ ಸಿಚುವೇಶನ್. ವೋಲ್ಟೇಜ್ ಫ್ಲಕ್ಚುಯೇಟ್ಸ್ ಅಂತ ಕೊಟ್ರೆ ಅಂತ ತಿಳ್ಕೊಳ್ರಿ, ಅವಾಗ ನೀವು 10 ampere ಸೆಲೆಕ್ಟ್ ಮಾಡಬೇಕು. ಏನೂ ಫ್ಲಕ್ಚುಯೇಷನ್ ಇಲ್ಲ, ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ ಅಂತ ಕೊಟ್ರೆ 5 ampere ಸೆಲೆಕ್ಟ್ ಮಾಡ್ರಿ. ಮಿನಿಮಮ್ ಅನ್ಬೇಕು ಮತ್ತೆ, ಮಿನಿಮಮ್ ಆಫ್ 5 ampere. 2 ampere 3 ampere ಫ್ಯೂಸಸ್ ಆರ್ ನಾಟ್ ರೆಕಮೆಂಡೆಡ್. ಯಾಕಂದ್ರೆ ಆನ್ ಮಾಡ್ಬಿಡ್ದು ಫ್ಯೂಸ್ ಹಾಕ್ಬಿಡ್ತೀನಿ, ತಿಳಿತಲ್ಲ, ಆನ್ ಮಾಡ್ಬಿಡ್ದು ಫ್ಯೂಸ್ ಹಾಕಿ. So these are some applied questions which you can expect. That's it from this chapter. If you have any doubts regarding the chapter, you can ask. Any doubts idre kelri ಒಂದು ಸ್ವಲ್ಪ. ಇಷ್ಟೆಲ್ಲ ನೋಡಿದ್ರಿ, ಕಲಿತ್ರಿ, ಮೋಟರು, ಜನರೇಟರು, everything you learnt on. If you have any doubts, you can ask. Almost 90 to 95% of the chapter I have covered. ಏನಾದರೂ ಒಂದು ಸ್ವಲ್ಪ ಎಕ್ಸಾಂಪಲ್ಸ್ ಉಳಿದಿರ್ಬೇಕಷ್ಟೇ, ಅದಕ್ಕಿಂತ ಹೆಚ್ಚಿಗೆ ಹೇಳಿದ್ದೇನೆ. ಮೋರ್ ದನ್ ದ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಇಸ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಟು ಯು. If you have any doubt, you can ask now. Any doubts?
No, sir.
No, sir.
ಗರ್ಲ್ಸ್ ಅದೇನಿಲ್ಲ, ಎಲ್ಲ ಮಾಯ ಬಿಟ್ಟಿದ್ರು, ಸೌಂಡೇ ಇಲ್ಲ ನಿಮ್ದು ಯಾರ್ದು. ಮೇಘಾ, so try to write the question answers which are given. ನನ್ನ ಕಡೆ ಇನ್ನೂ I have the no